and welcome to another episode of Wave of the Day by Smallest. I'm Emily, your AI enthusiast host, and joining me is the brilliant, ever curious Armin. Today's topic is something that's been turning the AI world upside down: deep residual learning. Armin, you've been buzzing about this one. What's got you so excited?
Oh, Emily, I can't wait to dive in. You know how the mantra in deep learning has been deeper is better? Well, it turns out that blindly stacking layers can actually backfire. A fascinating paper by Microsoft Research exposes this unexpected twist.
No way? I thought deeper networks were always better at capturing complexities. What's the catch?
Here's the kicker: when networks get too deep, they can actually perform worse. It's a phenomenon called the degradation problem. Think of it like overcomplicating a simple task, adding too many steps and ending up with diminishing returns.
Worse performance with more layers? That sounds so counterintuitive. Isn't a deeper network supposed to at least memorize the training data better?
Exactly, that's why this is so intriguing. The problem is that adding layers can make optimization harder. It's like piling bricks onto a structure without reinforcing the base. It just collapses under its own weight.
Okay, now I'm curious. What's the solution? Surely the researchers didn't leave us hanging.
They didn't. Their solution is called residual learning. Instead of making each layer learn a complete transformation, they have it learn the residual, or the difference, from the input. And to make this work, they introduced shortcut connections that let the input bypass certain layers.
I think I get it, but can you give me a real world analogy? What exactly do these shortcut connections do?
Imagine you're assembling a fancy dish. Instead of reinventing the recipe each time, you start with a basic version and just tweak it. Maybe add some spices or a garnish. The original dish is your shortcut connection, and the tweaks are what the network layers are learning. Much easier, right?
Oh, that's clever. So did it work? Were the results as impressive as they sound?
Absolutely. They managed to train networks with 152 layers, an unheard of depth at the time, and achieved groundbreaking performance. They won first place in the ILS VAC2D15 classification competition with a record low error rate of 3.57%.
Ow, that's game changing. And to think it's such a simple idea in hindsight, learning the differences instead of everything from scratch. Why didn't anyone think of this sooner?
That's the beauty of great ideas. Similar concepts had been explored in other fields like image processing, but applying it to deep learning in this way was a stroke of genius.
Before we sign off, what do you see as the biggest impacts of this work? Where do you think this will make waves?
The possibilities are immense. It's not just about better image classification. This approach has also improved object detection and localization. The team's methods have set benchmarks in multiple competitions. More importantly, residual learning is a versatile concept that could revolutionize how we tackle deep learning problems across the board.
And that, listeners, is why deep residual learning is such a monumental leap forward. Thanks for tuning into Wave of the Day. Armin, always a blast geeking out with you.
Same here, Emily. And remember, folks, innovation often lies in rethinking the basics. See you next time.